Okay, Assalamualaikum and good day to all. Now, we will proceed to the chapter 3, which is fluid dynamic, where in this chapter we will discuss related to the type of flow rate, mean velocity, the continuity, and also the concept of Bernoulli. So, as we know that Reynolds number related to your diameter, your velocity, your density of liquid, and also your mu. So, mu is the fluid viscosity. Okay. V is your average velocity. Density, if your fluid density is your rho, and di is the diameter of your pipe. So we know that our lamina flow less than 2000 value, and then the Reynolds number. Then for more than 4000 value of Reynolds number will be the turbulent. Okay. So here is the common parameter that used for the chapter 3, which is for the first is the Q. This is volume flow rate. So Q we always use in this chapter 3. Wake flow rate, W. Okay. And also mass flow rate. The common things we use is Q equal to AV. Okay, this is the main equation for chapter 3, where V is the velocity, A is the area of your pipe, then density of is the liquid of the fluid, and also the specific weight of the fluid here. We will use sometimes, depends on the information given. Okay. So this is the first concept of chapter 3, which is continuity. Continuity means that the mass flow rate has the same value at every position along a tube that has a single entry and single exit. Mean flow rate in equal to flow rate out. Okay, for this equation, for this diagram means that Q1, because we have point 1, and here point 2, Q2. So Q1 equal to Q2 because of the diagram only have one inlet and also one outlet. Okay. So this is your continuity, same as the previous slide. So Q equal to AV. So if you have Q1 equal to Q2, Q in equal to Q out. So Q equal to AV means that A1 V1 equal to A2 V2. This is for all the inlet, and this is for all the outlet. So next, okay, here also same concept, fluid flow. Okay, the mass flow rate is same at everywhere. So because it has one inlet and also one outlet. Okay, this also the same thing. You have Q1 and Q2. Here point 1 and here point 2. You have one inlet and also one outlet. So means that Q in equal to Q out. Q1 equal to Q2. Okay. So this one, Q1, for example, Q1 equal to Q2, right? So A1 V1 equal to A2 V2. This A related to your area, where A1 must calculate the area at point 1. So here your point 1, and normally our pipe is like that. So area for the pipe is circle area. So pi r square or pi d over 4. Okay, so that's your equation for the area. And then A.2 also depends on the area at point 2. That's your area of point 2. So depends on the diameter or radius of the pipe. So you can calculate the A at point 2. Velocity 1 depends, sometimes they give one of the velocity. So you can calculate the velocity based on all the information given in the question. For example, in this subtopic or this question, given the diameter of the pipe. So pipe 1 and pipe 2, this is diameter pipe 1 and 100 is diameter pipe 2. And then it also given the velocity at section 1 is 8 meter per second, means that this is V1. So from here you can calculate A and B. Okay, same, just use your calculator and replace all the information with also the area of the pipe. That first concept, this is continuity. Okay, if we refer to this diagram, also apply for continuity, whereby Q inlet equal to Q outlet. So first, we know that total Q inlet equal to total Q outlet. So for this part, we have one inlet, which is pipe 1, and we have two outlet, which are pipe 2 and 3. So this equation will be Q1 in equal to Q2 plus Q3, because we have two outlet, pipe 2 and pipe 3, so it represent Q2 and also Q3. And we know that our continuity Q equal to AV. So you just replace the AV inside the equation. Therefore, our equation become A1 V1 equal to A2 V2 plus A3 V3. Okay, so that's your final equation for the continuity. And then you just replace all the value by using information given in the question. So later you will get the value for the question given, either the velocity, the total flow rate. So you will get from the equation. That for the continuity. Then another one, we will consider the general energy equation. This equation related to the energy that involved in your system, where we know that we have the kinematic energy and also the PE, and detailed energy equation will given in the general energy equation. Here this slide represent the Q net. Okay, so this is all the related to the energy, the power of your of your system lah. Here Q net, so equal to energy over time. So if the question asks you the power of the system with the efficiency of blah blah blah, so you need to calculate the new power of your system. Okay, but this will be discussed detail in chapter 5. Okay. So here is your general energy equation. This is your general energy equation where P1 over rho 1 G plus V1 power of 2 over 2G. Okay. So as in the equation in the slide. So P2, so all the on the left one related to the liquid and point 1, but for the right one related to the liquid and point 2. So here is your equation as in the figure. And then this equation will be simplified as a Bernoulli equation when you know not involved with the energy system. Okay. For example here, if you have pump, so it related to your pump in your system. If you have turbine, it also related to your turbine in your system. But for chapter 3, we not involved with the energy equation, whereby we can cancel all the turbine and H pump and also the HL. This H turbine, H pump and HL, head loss mean HL, will study or learn in chapter 5. Therefore, when we simplify all the energy equation, it become the Bernoulli equation. Okay. So this chapter 3, we just need the Bernoulli equation, where Bernoulli equation same as energy equation, just they cancel the turbine, pump and also the H pump. So Bernoulli equation, you will got P1 over density 1 G plus V1 power of 2 over 2G plus Z1 equal to P2 the over density fluid 2 gravity plus V2 power of 2 over 2G plus Z2. That's your the Bernoulli equation that will apply in chapter 3. Okay. So this equation means that you have 2 points. You have to choose 2 points where point 1 and also at point 2. And all the information here related to your point 2 and information for the left one related to your point 1. So means that density of point 1, pressure of point 1, velocity at point 1 and also Z. And for the point 2, it also same related to all the properties and value at point 2. And to apply this Bernoulli equation, we have to know that all the assumption where we have to consume or assume that it steady state flow, friction and loss, okay, no shaft work, mean that this is no energy for pump or also turbine, because we will cover in chapter 5 this one. Incompressible flow, no heat transfer, okay, and also apply along the streamline. So normally we assume 2 or 3 in your question. So you can apply steady state flow, frictionless flow and also incompressible flow. Normally lah 3 point we also assume for the question, and we can apply Bernoulli equation. But for chapter 5, you cannot assume V pump, we neglect, because sometimes we also have the pump or turbine inside your system. So the detailed energy will apply in chapter 5. Therefore, for the overall summary chapter 3, we have 2 parts, which is continuity, where total Q in equal to total Q out. That for the first one. And the second one is the Bernoulli equation. So you have to choose point 1 and point 2. So you will use Bernoulli equation P1 over rho 1G plus V1 the power of 2. So you have to remember this equation because we not given the equation in the test or final. Okay. So that's all for chapter 3, and I will show you the tutorial after this. So thank you.